So hello, hi, welcome to the new lecture. So without delay, We will start lecture. So in last class, what we have seen? Tell me, SPN algorithm, and then after that we are seeing the random variables, and then using normal mathematical concept random variables, and from that using we have defined the bias, and then piling up lemma we have studied. Okay, so see, remember whatever we have taken in the last class is that SPN is how much, what is the plain text? Tell me how much the size of plain text. It is 16-bit, and ciphertext means SPN is a algorithm. If you give plain text you will get the ciphertext. So ciphertext how much? Again 16-bit. Okay, happy? Okay, so here uh, we have done SPN 4 rounds. Okay, 4 rounds, 4 rounds. Okay, and again SPN, this 16-bit, it is divided into 4 blocks. Okay, and each block is having 4 bits, and we have seen all these things. Okay, no need to explain again and again. Okay, so today we will see about the main motive why we have studied this mathematical concept means we will see about linear cryptanalysis. Okay, see, we have studied one algorithm SPN. If you give plain text, then a ciphertext will be produced from that algorithm. It is basically a cipher, you can think of. Okay, it is symmetric cipher. Okay, this is all discussed. So now on this on this network we want to attack it. So that's what linear cryptanalysis. So for that linear cryptanalysis we are slowly building up the concepts required to understand that linear cryptanalysis. So for that mathematical concepts we have seen in last class. So according to the, just like it is like foundation for the linear cryptanalysis, approximation table is also one part you have to study. Okay, by doing small means understanding all these foundation things, then finally we will do this linear cryptanalysis. Okay, so approximation table is one of them. It is a part. So approximation table generally, basically it looks like this approximation table. So you can think it is nothing, it's storing all the combination. I mean, the table contains in a way, this is count actually, but I can say it contains all the bias of all the random variables. Okay, we will see, don't worry. So for that we let's start here. Okay, here see, this is what they are defining. Okay, see, you have to remember these things. Let's say I am indicating x. X means it indicates whole of 16-bit and 16. Okay, see, capital X is our random variable which is relating to the plain text, and capital Y is our random variable which is relating to the ciphertext. Okay, this one you have to understand. So for one X box we will give 4-bit, and you will get the what you will get x1, x2, small x1. You will get the all small y1s, y2, y3, y4. So here what they are saying means, suppose if probability that see here they are considering the SPN network whose input has m bits. Okay, as a m bits means each block is having, each block is having the m bits. This you have to understand. But in our case, how will you write this thing? You will write like this: probability that capital X1 equals to x1 and so on, x4 equals to small x1 and so, capital Y1 equals to y1 and so on, capital Y equals to y4, that is equals to 0. Okay, if whatever the input if you give a input to the Xbox, it will produce output, right? If that output is not equals to this y1 y2 and so on y1, then it is probability is 0. This you have to remember. Okay, happy. So next we are saying that saying that probability that capital X1 X2 and so on Xm is equals to 1 by 2 power m. Why so means, because see, here we are basically applying basic fundamental formula that probability that A intersection, see, A comma B is nothing but probability. This how we are writing notation, probability of A into probability of B by A. So see bro, S box is predefined, means it is defined, it is not a secret, it is public. Okay, S box is a fixed function. So if you give a particular input to X box, then it definitely it will generate the definite output. Okay, not a probabilistic output. So by that, tell me this. So I am saying this probability equals to 1. Why means I am explaining. See, what does this means? The probability that and so on blah 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 equals to, and so given that x1 and so on xm equals to xm. Okay, here in our case n value equals to 4 and n value is also 4. Okay, don't worry. So y1 means, see, probability that capital Y equals to and so on, given that x1 x2 equals to 1, because here there is, see, probability 1 means what? It will definitely happen. That's what I discussed, right? Where I discussed here. So whenever, see, first of all, this 5s is a definite. Okay, when you give a known input, then output will be generated also a definite. There is no probabilistic in that nature. Okay, directly you will get definite. Means what I mean to say, definite means pakka correct result. Okay, see why the probability arises. See, if you take one coin, coin having heads and tails. One side is heads, other side has tails. Okay, when you toss it, then it will be land upon the land. Let's say it will land upon the land. Okay, on the ground. So here, see, now you are estimating, means probability that the coin will having head means, then you will say that 1 by 2. Okay, but suppose if both sides coin has having head, then pakka you can say that every time if you conduct the experiment, then you will get a probability equals to 1 only, right? So like that here also, since capital X is known to us and S box is a open and fixed, you will get a definite output. Okay, samjha? That's it. So then probability equals to 1. And see, here the probability of this thing equals to 1 by 2 power n. Why so means, see, here, see, initially only we have assumed in last class, let's say x1 x2 and so on, all are the independent random variables. So this can be written as, tell me, this can be written as probability of capital X equals to x1 and probability at capital X equals to x2 and so on, probability capital X equals to x3 xn. Okay, xm. So see here, bro, this x1 x2 x3 x4 are the bits. Okay, so this x1 can be either 0 or 1. Okay, x2 can be 0 or 1. Suppose, let's say if x1 equals to 0, then what will be the probability of x equals to 0? Then you will say that 1 by 2. Okay, variable outcome by total number of outcome, 1 by 2. So like that, since everyone is having two choices, this therefore 1 by 2 will become 1 by 2m. So why I am telling this means, from these two I can conclude that this is right, because of this formula. Okay, so this probability is 1 by 2 power and this value is 1. So this whole value is nothing but this value. Okay, fine, happy. So let's go to next. So once you got this basic understanding, now from this we can easily compute that bias of this one. Wait a minute. So by this all these things we can easily compute this bias of this random variable. Suppose if we have a random variable like this x1 x2 i2 and so on, some xi and so on, yj1 and so on, some yjl, some I, anything is some k, let's say. So from this concepts we can easily compute this biasness. Okay, happy? Nice. So for example just take this one. Okay, tell me this probability that x1 x4 x2 equals to 0 is equals to 1 by 2. Why? Because for this one you have to see this table. So actually this is the step 1. Okay, I forgot to say. So step 1 is nothing but see, each S box is having, like we are passing some x1 x2 x3 4 bits. You will get y2 y3 y4 4 bits. So I'm considering all the possibilities of x1 x2 x3 x4. It can be ranging. So since there is 2 power 4 16 possibilities, so I have written all these 6 possibilities. These are nothing but y1 y2 y3 y4. These are nothing but simple. See, you have passed through S box. According to the number you have converted into the binary. See, for suppose it is for 0, if you see the X box, the value is E is nothing but 14. So 1 2 4 8, so 14, right? Like this I have filled this table. This we have to keep in handy. So here they are asking to find this probability of x1 x4 y2 equals to 0. So how will you do it? Means you have to write like this: x1, what is that, x4 y2 equals 0. You have to solve for all the things and you have to use the formula favorable by total number of outcomes. Probability is favorable by total number of outcomes. Okay, this is the simple thing. x1 x4 y2. So now simply jar it. So I told now jar is nothing but just addition. So simple do addition: 0 0 y2 0. So all this thing is 1. Again 0 0 0. Okay, after that see what we have to find means this value is all will count how many number of times 0 happened. 1 2 3 4 5 6 7 8. So therefore probability is x1 x y1 x4 y2 equals to 0 is 8 by 16, 1 by 2. Okay, happy? Like that you have to find. Nice. So bro, ultimate our aim is to calculate the bias of some random variable. Okay, bias of random variable, let's say x, is nothing but bro, I forgot. I will tell one interesting property. Okay, this is known thing. Bias of a random variable x is nothing but probability that x equals to 0 minus 1 by 2, and this can be written as 1 minus probability of x equals to 1 minus 1 by 2, that is 1 by 2 minus probability that x equals to 1. Okay, now let's calculate bias of x bars. So probability that x bar equals to 0 minus 1 by 2, that is equals to x bar equals to 0 is equivalent to x equals to 1. X equals to 1 minus 1 by 2, that is equals to minus of 1 by 2 minus probability of x equals to 1, that is equals to minus of bias of x. So therefore you have to remember this, that key bias of x bar is equals to minus of bias of x. X is nothing but random variable. This is the property, and bias values is always belongs to minus half to half. This you have to remember. Okay, anyhow this is not relevant. Let's come to our topic. So basically this all these things, nonsense things we are studying means finally we have to compute the bias of a random variable. So if anyone asks, bro, bias of x1 x4 y2 how much, bro? If anyone asks this, the answer is probability this, let's say this is k equals to 0 minus half. So this value is of half minus half equals, therefore bias of k is 0. Like that you have to reply, means you have to solve not reply. Okay, chalo. Okay bro, nice. So here see, basically random variable, it's consisting of ZORs of our capital X. Capital X means it is a random variable relating to the cipher plain text, and capital Y is relating to the random variable relating to the cipher text. So we have to see basically I am having 4 bits of capital X and 4 bits of capital Y. So there can be possibilities of ZOR of every is having 2 times 2 choices, means I can write XOR x2 x3 x4 y1 y2 y3 y4. So I can have 2 power a2 means 2 power 56, means I can do ZORs of I can have a combinations of 256 times. Okay, means sometimes you can neglect this x2. What I mean to say means every time if I want to talk about some random variable, every time I have to write this much very big. What is na is a stupid word, don't use it. We have to write very big word, right? So for this one we are using some simple notation. Okay, that is using the hexadecimal notation. That's what here they have written it here. So means every time, let's say we have to find like for this random variable we have to find the bias. So every time we have to write very big, right? So for such thing, for our simplicity, what they have done means we will use our notation. Okay, so the notation is that very simple. Let's say we will use 2 hex bits. Okay, 2 hex bits, hex digits. Okay, let's say like this it is written. So now we have to do, what we have to do means, see, you have to see A corresponds to capital X and B belongs to capital Y. Okay, so A is 1 2 3 4, B is 1 2 3 4. Okay, see, if in the random variable if you see capital X of position 1, then mark it as cap 1. Okay, now since x2 is there, x belongs to A, and it is the, if you see with your eyes, mark it as 1. If you see with eyes, mark it as 1. Since x4 is not there, 0. Okay, here capital Y1 is 1, capital Y2 1 0 0. So now this convert to the hexadecimal. What is the hexadecimal? E. Now this convert to the, tell me how much, bro? 1 2 4 8. Okay, 12. So 12 is nothing but C. Okay, nice. Okay, so basically instead of writing this whole variable, means whole random variable, I can simply write now onwards like a comma b, like a tuple. Okay, I mean instead of a I can write like this, e comma c. If I write e comma c, then you have to understand like this. So I can write like, if I give a question like this, find the bias of f comma 3, how much value, how much. Now solve me. Please do this question. Okay, I will give 2 minutes to do this. You please do it. Okay, okay, time up. So first let's understand step by step. Okay, so whenever they written like this, first written fs like this 111. Okay, this first is nothing but a, it correspond to a, it corresponding to b, and 3 is 0 0 1 1. Okay, a is nothing but capital X, so this can be written as x1 x2 x3 x4 y1 y2 y3 y4. Now from this write the random variable. Okay, what will be the random variable? x1s are, x2s are, x3s are, x4s are, y3s are, y4s are. Okay, you have to find the bias of this one. So this bias of this thing is whole thing. Let's see this, let's name it as k. So k equals to probability that k equals to 0 minus half. So how will you find probability of this x1 x2 and so on y4 equals to 0 minus half? Means simple, probability formula is nothing but favorable outcomes by total number of outcomes. Okay, so total number of outcomes is like 16, right? 16. So 16 by favorable outcomes you have to count. So from where you can count means using this table. So bro, this is not approximation table. Okay, mind you, this is normal helping. Okay, so you have to find all these things, means you have to consider all these rows, x1 x2 x3 x4 y3 y4. Okay, chalo. So y3 y4. So now let's do it. So all zeros 1. See, zor is nothing but plus. So plus. So plus means just add it all these things. 0 plus 0 plus 0 plus 0 plus 1 plus 0. How much? 1. So this whole value will be 1. 1 1. This whole value will be 1 1 1 1 0. This whole value will become 1. This whole value, see, whenever you get 3, see these things. So this whole value how much? 3. So zor is nothing but addition, summation modulo 2. So 3 modulo 2 how much? 1. So that's why I have written 1 like this. Okay, here 1 1 0. Here becomes 0 0. Okay, 0 0 0. 1. Okay, like this you have to follow, bro. Simple, very simple. Okay, so from these things you have to find the probability of x equals 0. So count how many number of zeros. 1 2 3 4 5 6 7 8 9 10. So 10 by 16. So the so here bias will be, so 10 by 16. So therefore the value bias will value 10 by 16 minus 1 by 2 means 2 by 16, that is 1 by 8. Okay, very simple. Happy? That's it. So you have learned it. So very good job. Okay, so similarly you can find the bias of okay, so now tell me how many random variables possible. All the combination of random variables they're possible of 2 power 8 2 power 8. So that is equals to 2. This can be written as 16 into 16. Okay, so since random variables is denoted by a comma b, a comma b are like hex digits. Okay, hex digits. So how many total hex digits possible? 16. B value 16, so there can be total 256. So now we will take all this 256 and keep start the filling it. Okay, so by doing this thing, finally we will land up here. Okay, so you understand this table, how this table means. Since see, a comma b is nothing but a random variable. Okay, this is the just representation of random variable. So if a value 0 and b value is 0, then NL of a comma b. So see here, bro, since bias is equals to probability minus 1 by 2, probability is nothing but favorable by 16 minus 1 by 2. This favorable I am writing here. This is what they are calling as NL. Okay, simple thing, basics. So now tell me what will be the bias of I told what solve now something, some problem, f comma 3. So f comma 3, so f comma 3, just you can see this table very fastly, f comma 3, and you can proceed it. 6 by 16 minus 1 by 2, so minus 2 by 16 minus 1 by 8. Okay, so this is what I have to get it. Okay, see here I got minus 1 by 8, that means I have done something wrong in this thing. So you please do try it once again. Okay, you please do try this once. So that's why there are chances that there are more since we have to count these favorable outcomes. To count this to find this favorable outcomes, you have to carefully draw all these things from the step 1 table. Okay, so maybe I have done something wrong thing here, so that's why it came very badly. So you be please careful. Okay, okay, like you understand now approximation table. In approximation table is nothing but we are writing all the possible values of favorable outcomes for the all possible random variables. So there are total 256 random variables combinations possible. Okay, that's what we have written. Okay, happy? This is simple. So here they have given some nice formula, so you understand now this basic common sense. So whatever we have written here, this they have kept in this formula format. Means here all this each cell denotes the favorable outcome value, not the bias. So to get the bias, you have to find like this, or you can use formula. Okay, that's it. So that's all, like you have to know about it, about approximation table. So once the approximation table is this approximation table is finished, then we can go we can start the main thing, linear cryptanalysis, means linear attack. Okay, chalo. So see why we are doing this, all these nonsense things, means because from this approximation table we have to select this some random variables which will be used for our linear cryptanalysis. Okay, so we have to select the random variables in such a way that the bias, means modulus of bias should be higher. Modulus means you know, right? Mod 5 plus 5, mod 16 means 16, like this. Mod means modulus normally no. Okay, mathematics basic thing. So modulus of bias is higher. Okay, such select the random variable such that modulus of bias mode of bias is higher. Okay, for that one we are doing all these things. Okay, so next we will see about linear attack. So for that linear attack, let's see here. So here, see here, in this linear attack we are choosing the 4 random variables. Okay, so here question lies here, why we are choosing only these 4 random variables. For that you please watch the SAR video or listen the recording, I mean SAR video, or ask SAR directly. I am not sure about that. Okay, considering that we have selected those random variables, then what to do I will explain. Okay, don't worry. So consider these random variables. Okay, t1, t3, t4 and so on. So here see bro, 1 denotes that round number. Since SPN has having 4 rounds, 4 rounds means 4 plus 1 round keys, so 5 round keys. So round keys can be denoted as k1, k2, k3, k4, k5. Okay, anyway, this all these notations, I am just brushing up. Okay, so chalo. So see u5 means 5th bit. See previously in last we have used the notation of capital X. Capital X is a random variable which is relating to our plain text. Now here instead of capital X we are using bacha thing, capital U. Okay, and 5 denotes the position number. Okay, our plain text is 16 bit, our cipher text is 16 bit. So as per let's say 1 base indexing, this is 5 denotes that 5th bit in our U, means U is nothing but plain text, capital U is nothing but cipher. Happy? Like that you proceed it. Okay, now see, now my question is, see this random variable and please tell me the notation value. So notation value means according to generally random variables we are using the notation like it is represented by a tuple a comma b, but where a comma b are 2 hex digits. So how to find me? See u5, u7, u8 and something v6 is there. So bro, I will tell one formula. Okay, 5% mod. So this circle subscript, let's say subscript modulo 4 equals to this value only. Okay, the answer is subscript percent modulo 4 if answer is not equals to 0 and equals to 4. Answer is equals to 4 if subscript modulo 4 is equals to 0. Okay, so what I mean to say means you can consider this as, since you are not feeling the notation, let's u is taking as capital X. Okay, so now this can be thought as 5 is nothing but 5% modulo 4, so 1, this is x2, x2 na x3. Okay, and then 8% 4, 0 is nothing, so that's why take 4, so write it as 4. Okay, and v6 nothing but capital Y, and 6 is nothing but, tell me, 6% modulo 2. So from this I can see 1 2 3 4 1 2 3 4 1 0, remaining are these things. Okay, so tell me what is the value 4, 1 2 4, and tell me what is this value 11. Okay, 8 plus 3 11. Okay, happy. So that's it. So this is nothing but 11 comma how much 4, and see the approximation table and tell me the formula. So from this 11 comma 4 11 means nothing but what? B, right? So therefore the biasness will be calculated as 12 by 16 minus 8 by 16, 4 by 16, like this, 1 by 4. Okay, okay, that is how you have to calculate the biasness. Okay, so this see, I have told last class also, again I am revising it. So this indicates the round, which round it is, and this indicates the block number. Since we are having the 16 bits divided into 4 blocks, each block is having the 4 bits. Okay, that's it. Like this, you can think like this. 16 is divided into 4 blocks, and each block, for this block the numbering starts from 5 to and insert it. Okay, happy. So similarly like this you can calculate for this random variable in the same procedure. Means see, I will calculate within just 10 seconds. This is nothing but 2, this is nothing but 2, this is nothing but 4, so this is nothing but 0 1 0 0 and 0 1 0 1, this is nothing but 5, this is nothing but 4, so 4 comma 5, so 4 comma 5, how much? It is 4, so the formula is 4 by 16 minus 8 by 16, that is minus 4. So that's what same. Now we got it like that. Calculator. Okay. After that see, again we are taking assumptions that all these t1 t2 t3 t4 random variables are independent. Once these random variables are independent, then to find the bias of this whole value, let's say it is as a k, bias of k is nothing but how will you find this bias of k? Using simple formula of piling lemma. Piling lemma, it is nothing but, see, this is nothing but this. If whenever you got all these jars, and if it is, let's say all these are independent, then you can find this using this formula. So according to the formula, their k value is 4, so 2 power 4 minus 1 into bias of each variable. How much bias? T1 is nothing but 1 by 4, remaining all are minus 1 by 4s, so 1 by 4 minus 1 by 4 whole cube, and finally you got it. now so the next step, what we are doing means we are expanding all the use, all the use. So wherever you see use, you represent it as a in terms of x. Means see here u51 you can think of u15, this is called u15. So how to get u15 is nothing but x5 XOR with this k15. Okay, x5 XOR with k15, that's what we have replaced here. Similarly u7 u8 are replaced by like this. Okay, this is the step 1. Okay, and similarly u62, what is that value? Tell me. u26, sorry, u26, okay, this is called u26. Okay, u26 how will you get means, tell me. u1 6 XOR with k2. I mean, sorry, it's not you. So this value is v6 bro. v6 XOR with you will get here. Okay, so that's how basically expanding all use and keeping these as it is. This is the step. After this, next step is that again we will replace always. Okay, by replacing always we will get these things. Okay, if you want we can found it. Let's say v36, so v36 is nothing but here, where v36, So this is called v36. So how you got v36 means v36 v36 how you got means u46 plus v46. Okay, this v36 is positive here, so can I write like this? So we know that one property, right? X XOR y equals to z means X XOR z how much? Means if you take any two combination, the answer will be that another one. So y. Similarly, v63 is nothing but u64 plus k64. Like that, we find the values and replace all the v's. Okay. Once if you replace all this will, then you will get this random variable. So this random variable is nothing but t1s are, t2s are, 3t's are, t4. Okay. This is what we have get after all this expansion. Okay. Happy? So let's see about linear cryptanalysis definition. So linear cryptanalysis is nothing but a subset of plain text bits and the subset which is immediately preceding substitutions performed in the last round. So last round here, these values they are saying. So this is what we have found, right? All these values is a relationship between the subset of plain text and these things. Okay. So next, so what is the next step? Okay, the next step is, since capital K, so K is initial, let's say you can think of K is like a master key. From that master key we have done using master key, we have generated K1, K2, K3, K4, K5, all the round keys. Okay, since K is like master key and it is known between two parties, it is fixed secret key. I mean, what I mean to say, it is a secret key, it is fixed. So all these values are fixed. So when you XOR with all these values, then either it becomes either 0 or 1. Okay, so we can remove those happily and we can think this as a x1, x2 and so on, these things. Okay, happy? You understand my point? Why we are writing like this means this value can be thought of a 0 or 1, bro. And you know that this small properties, right? XOR with 0 means x only, XOR with 1 means x bar. So this for this random variable it can be like this. You can see here I have written very clearly that let's say before removing k, initial bias of this whole value is -1/2. After removing k, the bias can be become +1/3 -1/2. Why so means here because of this thing. Y means c. This whole value, suppose if it is becomes 0, then this whole value is nothing but this only. So and we this value is nothing but -3/2. Happy, keep it as it is. Suppose this whole value will become 1, then x1 bar, this one will become random variable of like this, then it will become x bar, and bias of x bar is nothing but minus of bias of x, as I have discussed previously. So then minus into minus will become +1/3. So this you have to understand it. Okay, chalo. So so here understand. So next step is that key, suppose let's say we are having t plain text ciphertext pairs. So t means these are known things. See, we know SPN network. Okay, SPN algorithm is public. So attacker, since we are talking in terms of linear attack, so let's assume that assume ourselves as a eavesdropper or as some scammer or hacker. So let's say by somehow somebody given this t plain text ciphertext pairs. Okay, using these things now. So the aim is clarity here only, bro. The aim is that attack means do some nonsense things and finally achieve the meaningful thing. Okay. So attack here means by doing these things, we know t, let's say t can be like in any number, okay, 5 6 7 or 1000 10,000 8,000 9,000. So some known pairs, t is a number of pairs. Suppose this is plain text. So using this pat t pairs, he will do some pattern observation. I mean, you can think like that in simple words. You can do pattern observation, and finally he will get the key. K means master key. Means basically secret key is he will get. Okay, chalo. How will you get means we will see here. You got my point. This attacker, what he will do means using the known ciphertext and plain text, he will be able to find the master key. That's what I want to say. So I have said in a very stupidity way. Okay, so as per experiment results, they have shown that if he can have 8,000 pairs plain text ciphertext pairs, then he can achieve easily. I mean, he can achieve the attack success easily. Attacking successfully easily means secret key he will get more. Okay. So next, let's say this set of t pairs by tau. So tau is nothing but a set of pairs. So SAR notation is like this. Tau is nothing but pt comma ct, and it is ranging from 0 to 1. pti comma cti, and I is ranging from 1 to 10. So mod tau means cardinality of this set tau is equals to capital T. Capital D is nothing but nearly 8,000. Okay, happy. So next step. So whatever this attack, okay, I mean whatever the algorithm which I am going to discuss, this algorithm, from this algorithm I can able to get the 8 key bits. Okay, what? 8 key bits of what? Of not a master key, it is a 5th round key, okay, of a K file. So see, whenever we written this in this square bracket format, this means that it is a block number. So for second block means we are having 4 blocks, right? So second block index starts from 5 6 7 8, and fourth block index starts from 13 14 15 16. Okay, this keys we can able to found, okay, by using this algorithm which I am going to discuss. Okay, how we will get this means how the algorithm works, this we will discuss here. Okay, happy. See bro, actually this algorithm what we are getting here, okay, this it will tells these 8 bits. What are the exactly 8 bits? Okay, generally let's say how many number of possibilities for this 8 bits? There will be 2 power 8, 2 power 56 possibilities. Okay, I mean 2 power 8, sorry, that is equals to exactly 256, sorry, right. So 256 possibilities are there. So since there are 256 possibilities, now tell me one thing, using the algorithm you will get the pakka one. That's the beauty here. Okay, so they are calling this 8 bits is as a candidate subkey. Okay, happy. That's it. So how the algorithm means whatever the algorithm written here, we are now telling verbally. Okay, so for each x comma y tau, and for each candidate subkey, it is possible to compute the partial decryption of y and obtain the resulting value of u2 and u4, and then we can compute this value of these things. Okay, blah 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 blah, and so on these things. So that's it. Okay, let's see algorithm directly. You will understand more better. Okay, see, you got my point. What I meant to say. What is the algorithm purpose, attack purpose? Using this attack you will get the candidate subkey. Candidate subkey is nothing but fifth block of 214 means K5 of 214 blocks keys will means we will get 8 bits key revealed. Okay, how means we are following this. See bro, since 8 bits is a candidate key, what that candidate 8 bits is a candidate key, so 4 plus 4. So let's say K5. K5. So K5 means how much? Tell me. 16 bit, right? So 16 bit, you can think 16 bit as a okay, leave about it. So candidate subkeys. So K5 to tell me mod value, not mod value. So length of this. So len of mod is used for cardinality, means for sets, but this is like normal bacha string, no? So we'll write as a len 4, and this len value is equals to how much? 4. Okay, so 4 means I told no how many total possibilities will it having candidate subkey. It can have 256 2 power 8. So this 2 power 8 we have, it can be written as 2 power 4 2 power 4. 2 power 4 means 1 hex digit, and this is 1 hex digit. So let's denote this candidate subkey by L1 comma L2. Okay, now what we are doing means, so this algorithm starts like this. So actually we are creating one count table. Okay, the count table is looking like this. Okay, count table. So count table 0 1 2 and so on f, and 0 1 2 and so on f. This is the count table. Okay, happy? See bro, this is simple thing, you don't fear at all. This is bacha things, even normal a 8th class bacha also can understand it. All you need is that you have to listen very carefully, that's it. So initially we are initializing all these things as 0, each cell as a 0. Okay, okay, happy? So next one, since see what is tau is having like pt1 ct1, pt2 ct2, pt3 ct3, and so on like this. 8000 pairs are there. So pt1 ct1, let's take one pair. Okay, samjha, one kick ray. If you don't understand, I will come and there one kick, then you will mind will set and you will be able to listen. Okay, take one thing, one. So for each thing, so and so basically bro, you can think like this. For each c1 we are seeing all these 2 power 56 possibilities, and for each possibility we will increment each cell according to the condition that this random variable value is 0. If it is value 0, then we will increment as a 1. If not, then shut up, like that. Okay, see here all these nonsense things are written here. So how they written means simply here. Look here bro, see our intention is what? Tell me. Our intention is that we have to find the z value. So we are setting one condition that whatever this random variable, if it is 0, then we are incrementing it as a 1. This is what they are taking. So now the question is that what is this value? Means this xy, x7, x8, this can be got from this pt1. Okay, happily we can got. we will get. And how to find this term means u6 u8 u. How means just use your common sense. See here, this is nothing but the finding the block numbers of u4 second block and u4 fourth block. If you can find these block numbers, then it is done. Okay, so observe that one means you need to find these values. So now we will generally we have gone like this. Now we will do in a reverse process, because we know y value, we are taking k5 as each and every possibilities, or brute force like that, all possibilities. So from this, can you get this one? Yes, we can get. So let's say y2, let assume that this is S box. So let's say u4 is applied on S box, then you will got v2 of 4, and v2 of 4 is XOR with k5, then you got y2. Okay, now just do it by in a reverse way. Means from this, what can I write? Tell me. y2 can I write like this, v2 4, and what is the v2 4? v2 4 can be written as just apply the pi inverse. So u2 4 equal v2 4. Okay, now what we have to do means v2 4 you have to send through the pi s inverse. You have to send to the inverse of S box function. Okay, if you send it, then you will get the pi u2 4. So from this you can write like this, u2 4 can be written as pi inverse s inverse v2 4. So this, from this equation, very bacha equation, they have written like this complex things. Okay, similarly here L1 is nothing but I told right, L1 is nothing 8 bits. So I explained here. If you want, you can go back on it again. So from this here, first it will become v4 and then apply s inverse, then you will get. So once you will get these blocks, then see this block number contains what are the bits number indexes. This block number contains 13 14 15 16. So from this one we will use this whatever we required, and then we are setting this condition. If z value is 0, then we are incrementing equals to 1. If not, then silently keep it as it is. Okay, this is the whole about algorithm. So for that like that, how many times we will do means we will do for each and every tau. Means after this done, then we will take the p2 c2. P2 means plain text 1, ciphertext pair 2, and then like that we will do for 8000 times. Once it is done, now what will you do means out of all this from this table we will pick one cell. Okay, and declare that cell as a candidate subkey. And declare that one cell as a candidate subkey. So how we are doing means here, see this, don't fear at all, this is normal bacha thing. So it is assumed that basically it is assumed that whatever the values here we are getting count, this all counts, all counts are greater than t by 2, means t means 8000, so it is all greater than 4000. Nearly the value will be all becomes 4000. So since 4000 is everywhere in each and every cell, let's say we will subtract t by 2, so to get a uniformity. Okay, chalo. So for each and every round we will subtracting as a t by 2. Okay, and we will take the modulus value. Okay, so after taking this modulus value, then we will find the max of all these cells. What this is indicating is simply max of all cells. So the one which is having the maximum value, we are taking that cell, we are declaring that cell as a what, candidate subkey. Okay, so my L1 and L2, so this is called L1, this is row L is L1 and this column is L2. Bacha now, very easy now, right? That's it. So finally we have declared the maximum candidate key, I mean candidate subkey. So that's it. Happy? Okay, so after that so like what sir said in the class means think about yourselves only. So sir is saying that since we have found K54, sir is saying that since we have found, similarly use this algorithm and start from the beginning of the algorithm, I mean choose some random variables again. Okay, some random variables, find the compute the basis, I mean what you call this is basis only. Okay, compute the basis and start again and finally find these things. So by doing this one you will whole get a K5. So once you got K5, do this similar procedure for the fourth round. So by doing this fourth round, once you got to know what is the value of K5, then you can exactly know the what is the value. So similarly apply the procedure to here also, to K4. So similarly you will find like this K4, and then using K4 you will find the K3, using K3 you will find the K2, K1. So using this K1, so finally we got the master key. I mean you can think of secret key, bro. This is what we have achieved. Samjha? Happy? Cool? That's it. So finally we have achieved the secret key. So this is what the all about linear cryptanalysis. So simple, right? That's it. That's it. If any doubts are there, then you can ask the sir. I mean I can you have to read the book if you really want to get to intention, but here why I am explaining this much 1 hour time waste I am taking is just to make the confidence, just to feel the confidence in you. I am making this nonsense videos. Okay, because see this whatever this NTMC, this is bacha subject only. Even normal, even 8th class kid can get it. Means at the end of the day we have to get the aim for 10 pointer. And I have seen like many normal people who is more talented like me, instead they because of fear they are getting less marks. Means I don't want anybody to become like me. Means in other subjects, some other subjects I am having like fear problems, and I neglected them, and finally I will become like a dog, means very less pointer. So instead of becoming like me, so to make the feel your confidence in you, I am making these videos. Otherwise you can normally watch the SAR videos, but for SAR videos if you don't able to connect it, then try to listen to my video. Okay, I feel but my video also very bad only, but let it be. Like your understanding, no, because of one person understanding my lectures I am making, and that's it. Okay, chalo then, bye bye. If you really like the video, just comment or message me like Jai Sri Krishna. So bye.